Welcome to the presentation on ultrasonics. I am Ms.K.Janani, Assistant Professor, St.Joseph's College for Women, Tirupur. These are some of the objectives of this video. Ultrasonics, properties, production of ultrasonic waves, magnetostriction generator, construction, advantages and disadvantages of this method, piezoelectric method, construction, advantages and disadvantages of this method, sonogram, ultrasonography, fetal movement and heartbeat, medical application, sonar and references. Ultrasonics. What is sound waves? The human ear is sensitive to sound waves in the frequency ranges from 20 to 20,000 Hz. This range is called audible range. The word ultrasonic combines the Latin roots ultra, beyond, sonic, sound. It having the frequency above the audible range, that is above 20,000 Hz. It has the applications for imaging, detection and navigation. The broad sectors of society that regularly apply ultrasonic technology are the medical community, industry and the military. Properties of ultrasonic wave. It has high energy content. The waves get reflected, refracted and absorbed. It is transmitted over large distance with no appreciable loss of energy. It serves as a diffraction grating called an acoustic grating. It produces an intense heating effect. Production of ultrasonic waves. The ultrasonic waves are not produced by an ordinary method. It is produced by the following two methods, that are magnetostriction generator and piezoelectric generator. Production of ultrasonic waves by magnetostriction method. Principle: when a rod of ferromagnetic material like nickel is magnetized longitudinally, it undergoes a very small change in length. This is called magnetostriction effect. The change in length produced in the rod depends upon the following three factors: the strength of the magnetic field, nature of the materials, and it is independent of the direction of the magnetic field applied. A nickel rod placed in rapidly varying magnetic field alternatively expands and contracts with twice the frequency of the applied magnetic field. By adjusting the frequency of the alternating magnetic field to be equal to the natural frequency of the longitudinal vibrations of the rod, a resonance is produced. Due to these resonance, the vibrations of large amplitude produced in the rod. Ultrasonic waves are emitted from the ends of the rod if the frequency of the alternating magnetic field is more than 20 kHz. Now we see the construction of magnetostriction ultrasonic generator. A short permanently magnetized nickel rod is clamped in the middle between the two knife edges. A coil L2 wound on the right hand portion of the rod. C is a variable capacitor. L2 and C forms the resonance circuit of the collector tuned oscillator. Coil L1 is wounded on the left hand portion of the rod is connected in the base circuit. The coil L1 is used as a feedback loop. Let us now see the working of magnetostriction generator. When the battery is switched on, the resonance circuit L1C sets up an alternating current of frequency F is equal to 1 by 2 pi root of L1C. The current flowing round the coil L1 produces an alternating magnetic field of frequency F along the length of the nickel rod. The rod starts vibrating due to magnetostrictive effect. The vibrations of the rod create ultrasonic waves. The longitudinal expansion and contraction of the rod produces an EMF in the coil. This EMF is applied to the base of the transistor. Hence, the applied magnitude of high frequency oscillations in the coil L2 is increased due to positive feedback. Developed alternating current frequency can be tuned with the natural frequency of the rod by adjusting the capacitor. The resonance condition is indicated by the rise in the collector current shown in the milliammeter. Now let us see what are the advantages and disadvantages of this magnetostriction generator. It is very easy to design, its production cost is low, It has large power output without the damage of an oscillatory circuit. Now, what are the disadvantages of this magnetostriction generator? It cannot generate ultrasonic frequency about 3000 kHz. Frequency of the oscillations depends on temperature. The energy loss due to hysteresis and eddy current are high. Production of ultrasonic waves by piezoelectric crystal method. What is meant by piezoelectric effect? If one pair of the opposite phase of the crystal is subjected to a pressure, then the other pair of the opposite phase develops an electric charge. This is known as piezoelectric effect. Now, the production of ultrasonic waves in piezoelectric crystal method involves principle of inverse piezoelectric effect. Now, let us see what is meant by inverse piezoelectric effect. If an alternating voltage is applied to one pair of the phases, the opposite phases expands and contracts periodically, thereby generating an elastic waves. Example, quartz, tourmaline and rock salt. When a quartz crystal is subjected to an alternating potential difference along the electric axis, the crystal is set into elastic vibration along its mechanical axis. If the frequency of the electric oscillations coincides with the natural frequency of the crystal, the vibration will be of larger amplitudes. If the frequency of the electric field is in the ultrasonic frequency range, the crystal produces the ultrasonic waves. Now, let us see the production of ultrasonic waves by piezoelectric crystal method. Construction. It is a base-tuned oscillator circuit. A slice of quartz crystal is placed between the metal plates AB so as to form a parallel plate capacitor with the crystal as a dielectric. This is coupled to the electronic oscillator through primary coil L3 of the transformer. The coils L2 and L1 of the oscillator circuit are taken from the secondary of the transformer. The collector coil L2 is inductively coupled to the base coil L1. The coil L1 and the variable capacitor C1 forms the tank circuit of the oscillator. Now, let us see the working of the piezoelectric crystal method. When the battery is switched on, the oscillator produces high frequency oscillations. An oscillatory EMF is induced in the coil L3 due to the transformer action. So, the crystal is now under high frequency alternating voltage. The capacitance of C1 is varied so that the frequency of the oscillations produced is in resonance with the natural frequency of the crystal. Now, the crystal vibrates with large amplitude due to the resonance. Thus, high power ultrasonic waves are produced in this method. Now let us see the advantages and disadvantages of the production of ultrasonic waves by piezoelectric crystal method. Ultrasonic waves as high as 500 MHz can be obtained. Output of this oscillator is very high, not affected by the external factors such as temperature and humidity. It also has some disadvantages like the cost of piezoelectric quartz crystal is very high. Cutting and shape of the quartz crystal are very complex. One of the main applications of the ultrasonic sound waves are sonogram. It is a graphical representation taken by the reflected sound waves from organs and other interior parts. It uses the principle of Doppler effect, that is, there is an apparent change in frequency of the reflected signals. Some of the applications of ultrasonography are to confirm fetal viability, to determine the location of the fetus, to check the location of the placenta in relation to the cervix, to check for the number of fetus, to check for major physical abnormalities, to access fetal growth, to check for fetal movement and heartbeat, to determine the sex of the baby. One of the main applications of ultrasonography is to detect the fetal movement and heartbeat. It involves the principle of Doppler effect. Doppler effect is defined as the noticeable change in frequency of sound, light or water waves as the source and observer move. An example of the Doppler effect is the frequency of the sound increases as the source moves close to the observer. The block diagram shows that Due to the magnetostriction generator or the piezoelectric effect, and ultrasonic waves are produced. This is passed through the ultrasonogram and it is transmitted to the fetus. The heartbeat of the fetus is received in the receiver. The transmitter signal and receiver signal are mixed to produce a large amplitude which is amplified by using the amplifier. The sound waves are recorded in the loudspeaker and the observations are seen through the CRO. Some of the other medical applications of ultrasonics are used in cancer treatment and neurosurgery, to clean teeth and also for dental cutting. It is used for cataract treatment. A fetus in the womb can be viewed in the sonogram. Focused ultrasound may be used to break up the kidney stone. Low intensity ultrasound has the ability to stimulate the bone growth. Ultrasonic guides the person who is blind, uses the ultrasonic guiding stick as a guiding tool. The another major applications of ultrasonic waves is sonar, which is sound navigation and ranging. It uses the principle of echo effect. Ultrasonic waves sent from a point which is travel through seawater and get reflected back from the bottom of the sea. The reflected waves are received at another point. Using a CRO, the time taken T is noted. For the ultrasonic waves to travel to the bottom of the sea and reflected back to the surface can be calculated, where V is the velocity of the ultrasonic waves in seawater. The depth of the sea can be calculated by V into T by 2, which is 2D equal to Vt. The same method is used for finding the distance and directions of the submarine. The change in frequency of the echo signal due to Doppler effect help to determine the velocity of the submarine and its direction. The whole system is known as sonar. So, by learning the ultrasonics, we can have a large applications in science, industrial, ultrasonic welding, ultrasonic soldering, drilling and cutting. It is also used in metallurgy, alloys, etc. These are some of the references for the ultrasonics. Properties of Matter and Sound by R. Murugesan, Modern Physics by R. Murugesan. Thanks for watching.